back to my series on choosing PC fans or computer fans. Um, there's one really interesting thing that you need to know. Well, it's not one thing, it's several things, but it's about devices that you can use to make it more convenient for you to connect and control your fans. And so this is about controlling and daisy chaining. Daisy chaining is where you can have multiple fans connected to each other in a series. There are a wide number of devices, cables, and adapters that can be used to control and or connect devices in a series. Virtually all of these devices handle the signal of the fan and or LEDs between the control port, which can be red and or marked port 0 or port 1, and wherever it's connected for power. Often fans must be connected in series, like that, starting with the first port without any empty ports for DC and PWM, but this may not be necessary for LEDs. Power carrying options can have 2 or more wires, with 2 to 4 being the industry standard. So that's 2 for straight DC, that's 3 for DC with extra control, and then that's 4 for PWM, which is DC that has pulse wave modulation, which means that it pulses the power on and off to control the speed. Let's see. Power carrying options can have 2 or more wires, with 2 to 4 being the industry standard again. And more than that, usually handling both power and lighting combined with one socket and plug in order to reduce the number of cables. For example, this one this is combined lighting and power on a 6-pin plug. Okay, aside from using a low noise adapter or LNA cable, which slows down the fan to reduce noise, some fans such as the Phanteks T30 and the Be Quiet Silent Wings Pro 4 have a power mode switch, which you can see right there, that is usually built into the fan, making it very inconvenient to switch once installed. And quite honestly, it's pretty tight. So you have to be very careful if you want that middle selection. Otherwise, you're going to slide right past it. However, these more expensive fans effectively provide 2 to 3 fans in one, allowing more flexibility for the user. And I almost didn't buy this because, as a regular user, I don't really need a fan that has different power modes. However, as a tester, I definitely do need to test this out and see how those different modes compare, because they aren't necessarily equivalent to the other fans in the series that aren't built in or don't have this built-in switch. So the other Silent Wings fans from the fourth series don't have this. Okay, it's only the Pro 120, the Pro 140. This is a 120. Have this, and there are other ones that are slower than this, but only offer 1 power mode instead of 3. So, and they're a lot cheaper than these, and these are heavy. All right, so that's the first one. The second one are splitters. The most common is the Y splitter, like this, where this end plugs into the header or into the port, and these ends are the sockets for the fans to be plugged into. It allows you to add 1 additional fan, as you can see, and is included by default with fans from some brands. Like, for example, Antec tends to provide these by default. So does Noctua, except for on their commercial products. Some fans have a permanently attached splitter, like this. Oops. Trying to get away from me. Like this Thermaltake has got permanently attached splitters for both ARGB and PWM. Well, which may provide extra cable length. See that? While others provide very short splitters to minimize cable mess, such as the Phanteks T30. which I can't show you because it's inside of my case. There are also splitters that are designed to handle more than 2 fans, but most manufacturers sell these separately. So you might see one with 3 or 4 or even more to split it, but there's a limit because number one, when you plug it into a header, most headers usually only provide up to an amp of power, so you won't be able to take, say, 3.55 amp fans and use a 3-way splitter. You'll only be able to use it. You won't even be able to use a 2-way splitter because 0.55 plus 0.55 is 1.1. You're over the limit, which can lead to damage to whatever the splitter is connected to, not to mention the splitter and the fans. Yes, there are limitations to technology. If you have basic skill in wiring, you can make your own. Yay! Now you will have to buy wires, and you will have to buy the sockets and the plugs, and the pins. But aside from that, it's not difficult. Any fan socket after the first one in a splitter will usually have 1 pin missing, which is the PWM reporting wire, since that is sent between the first fan and the device or motherboard header only. There are also RGB and ARGB splitters, but I don't have any, I don't think. Okay, so you can, I don't know how well you're going to be able to see this because the stupid thing always wants to focus on my face. All right, yeah, you can kind of see that. All right, we'll do it this way maybe. You can kind of see that this one, the bottom one, has got 1, 2, 3, 4. See that? There are 4 pins in it. This one, however, if you look carefully, one of the pins is missing. And that's because this is the control one. So the signal information goes back and forth on this one, and whatever information is gotten received at this fan is sent to all the other fans in the series. So it doesn't matter how many you've got connected, they're all going to be running at the same speed as this one based on percentages. And the reason this one doesn't have that 1 pin is because that 1 pin is for reporting a signal, which you can think about it as a master and slave relationship, but not really. I mean, in the old days, we used to refer to hard drives that were put into the computer that if you had a SCSI, you could daisy chain them, and the first one would be called the master drive, and then all the other ones after that, up to X number of daisy chained SCSI drives, were called slave drives. But yeah, not exactly the same as this, but close enough. Yeah, and so again, you can see here, we have got a 4-pin socket, a 4-pin plug and a 3-pin socket for the next fan on this Thermaltake. Also, when I first saw this, I was a little bit confused by it because I had never, dealt with ARGB before. So here is the here is the plug. You can see that the middle pin there, middle hole there, is blocked, and that's because all ARGBs only use 3 of the pins, whereas RGB will use 4. And this is, if I can get the thing off, there. And there you go. You can now see the 3 pins. So now, obviously, this is not what you're going to be doing in reality, but you want to make sure that you line up the holes in the pins, because if you don't line up the holes in the pins right, you're going to break the pins. I mean, because some people will just force it and force it and force it until it's broken. So, and these are delicate, so you need to be careful with ARGB cables, because they chose stupidly thin pins, which they should have learned, because historically we've had these kind of really thin pins on certain things in the past, and it's always been a bit of a disaster. All right. So the third thing is internal splitters. Now, I don't have any fans with internal splitters because they're pretty expensive. But some fans, such as the Lian Li Uni fans, use hidden connectors to daisy chain both power and LED control, which looks great because there are no exposed wires except for the one wire that's going off to the motherboard header or to the controller or whatever it is. But aside from that, no cables. But it does require that each fan be in direct contact with the next one. If you want a very clean look, these are a great choice. One drawback of this connector is that the pins can be easily broken off or become stuck, resulting in malfunctioning fans. From the first fan that is damaged, every fan after it in the series will exhibit the same problems. Yeah. So I did actually see an example of this on the Linus Tech Tips forum yesterday, I think it was. A guy was posting about how his Unifans were one of them, the last one on the person's AIO was okay, except for sometimes the LEDs would kind of freak out. And that, you know, to me immediately, that was obviously some kind of a malfunction dealing with hardware because it was only the one fan. And I'd never had any experience with this kind of fan. So another person explained that, well, it's the pins. And yeah, so if that fan had been in the first position, the kind of master position, the controlling position, all the fans, including that one that were after it, would all have displayed the same malfunction. If it had been the middle fan, only the middle fan and the end fan would have displayed that malfunction. So it can look like more than one fan is malfunctioning when it's actually the first one in the series that has that problem, that is sharing, I guess you could say, that problem with the next one, because it's all in series, it's not parallel. And parallel wiring is a little bit differently because it forms like, I guess you could say, like loops. And each loop controls a fan separately, and they all go back to the same cable. So if you can imagine it, there's a cable running, instead of it being in series, there would be a cable running along like this, and on each side it connects to the fan. And then the next fan connects to that same top cable and has its own loop. And that's a parallel circuit. So if one goes bad or has a problem, it doesn't affect the other ones. Let's see. Oh, the next one are repeaters and nodes. These are almost the same as a splitter, except for the fact that it uses a little circuit board and is most often mounted inside the case by the manufacturer. Nodes are usually the term used for lighting units, while repeaters are usually the term for fan units. Both differ from a splitter in another way. It usually is powered by the power supply directly, most often via Molex D or SATA. If you want to know what that means, well, let me see. I've got a Molex D right here. And if you've been around for a while, you've seen these. I hate these things. The pins, especially when you're trying to connect them to each other, tend to move around if you don't hold it exactly the right way. So it can be hard to align them. But this one is also for daisy chain, because you can see there's a socket on one side with the pins, and there's a socket on the other side with the holes. So you can daisy chain several Molex D fans together as long as it doesn't exceed whatever the power supply is from the power supply unit. So yeah, and you can also see that this is actually a splitter going from a 3-pin DC plug. Oh my God, I hate that. From the DC plug to this Molex plug. And I can also show you a SATA plug. If you just give me a second, come with me. Okay, we're going to take a little trip. I've actually got both cables coming out of my computer to use for controlling things. So again, that's the Molex. And then this one, come on, focus on my hand. Or not. You know, you'd think you'd want to turn on the flash. There we go. There it is. So there's the SATA. This is the plug. Or actually, this would be the socket, because the plug looks like that. And this is actually the plug part. of a SATA connection. Although you can find them connected to USB or even a wall outlet in some cases. It is also connected to the motherboard header or headers and has no ability to control the fans connected to it. All control is through the motherboard BIOS and or software. Since they are mounted inside the case, they often don't have a protective case of their own. So using my computer as an example, I've got the Corsair iCUE 5000X RGB mid-tower ATX case. Yeah, I say that 3 times fast. And it came with both the repeater for the PWM and the lighting node for the RGB. It's not an it's not an ARGB lighting node, it's RGB lighting node. And those are built in, and they're just simple little PCBs that have ports on them. They get power from the power supply unit, and they connect to the headers. So the PWM connects to the PWM header on the motherboard, and the RGB connects to the RGB one on the header on the motherboard. So they are almost the same as splitters, right? Let's see, what else was there I wanted to tell you about that? Yeah, there's nothing else. Okay, let's go on to number 5. Hubs look similar to repeaters, but most often have a case around the circuit board, get power from the PSU and connect to headers, and are more expensive. So, for example, I've got a basic one right here, and this one this is actually more like, I would say this is actually a repeater because it doesn't have its own power supply. So I would take the repeater and this is a repeater. So this is a repeater. You can see I've got the PWM cable right here, and I've got 4 ports here to connect 4 PWM fans to it. And you can see that red I was talking about. So that's the control port that has to be filled in first. If you skip one of these, every fan after it will not work or will not work correctly. And then this goes to the motherboard header. And yeah, so that's a repeater. Now, in contrast, let's look at an actual hub. So this is a hub from Asiahorse. And this is actually a pretty complete one. It's got the red one there. In this case, it's not what you think it is. It is actually the power. So we've got the one for the ARGB. You can see that there. And where's my other one? And I've got one for the power. So the power, if you look at that, you can see it looks normal, but then you look at this thing and you can see that is quite different from this one. It's rather bigger, the regular one. So you have to align the notches up and plug that in, and then this gets plugged into the power supply usually, because that's a MolXD. Then if you have any LED strips, you can connect the LED strips over here on these 2 ports. So if you've got RGB, okay, if you've got RGB, you can connect RGB here. But if you have got if you've got their proprietary fans, like this is the Asiahorse Magic C, and let's see what happens when you do it. So if we look again, remember standard is 4 for PWM. This has got 6. So you plug this one into, let's see, I'm a fan. This can do up to 10 of their fans that have this kind of connector. So you plug it in and make sure it goes all the way in. Everything has to be plugged in very tightly. Then if you where is it? in order to control the ARGB, gosh, they wrapped this twist tie so tightly that it actually ruined the insulating plastic of it. So then you take the ARGB connector, which again has this teeny tiny, oh my god, let's compare this to my Thermaltake. Okay, standard ARGB and this custom one that Asia Horse is using. Big difference, right? So, but it converts from this tiny thing to this big one, the normal one. So you take that and you plug it in next to the power, which is right there, and make sure to line up the nubbins, the slot, and oh, it's not so easy. Oh, I had it turned around. Just doing the wrong one. There is also a another port over here. So that was a 3-pin. This is a 2-pin port for resetting. But I haven't looked into how that works exactly. I assume I could just put a screwdriver across it to connect the 2 pins, and that would reset the whole unit. In any event, so we've got this. This, again, we have 2 LED strips. We've got 10 ARGB fans. We've got the motherboard, this going to the motherboard ARGB header. And then we've got this one over here. However, you don't actually have to connect it to the motherboard header, because if you just plug it into the power supply, which I'm going to do right now, if I can, yeah. And hold on, it's a struggle to get this connected because of these stupid Molex things. So now you can see that I have got the fan connected to the hub, to the power supply, and that's making it zoom, zoom, zoom. However, we're not done. You'll notice it's got some see-through plastic wrapped around the sides here, and that allows you to see this. Kind of cool, right? I'm using a remote control that comes with it. So you don't actually need to connect it to the motherboard. Now, one of the nice things about this particular hub is that you can use either the remote or you can use the motherboard, which gives you full flexibility. So you can do it through the motherboard software. You can do it through the remote control. You can do it through third-party software like OpenRGB and Signal RGB and fan control and all that kind of stuff. And so there are different ways you can control it. You can control, there are certain presets for colors. I'm not really fond of these because, okay, so I'll tell you what these are supposed to be. That's supposed to be white. And this is supposed to be green. Looks blue to me, blue-green to me. This is also supposed to be green. Oh, there we go. That's the real green one. The other, on the remote, the top and bottom middle colored ones look exactly the same. See that? They look the same to me anyways. And then we've got 2 different purple ones here. That looks purple. That definitely does not look purple. We've got yellow and a lighter orange. And we got a darker, oops, I pressed the wrong one. Darker orange. And then we've got red. And there's another, no, that's kind of an orange red really. And then we've got this darker one down here. And that looks like purple, but it's marked as red. See that? And so it's a little bit confusing. However, if you don't want to use the presets like that, you can do the other things here. So we've got the S plus and S minus, and that slows down the fan. You can see this, the fan is changing speeds. I'm not sure how slow it goes for minimums. If it stops, nope, it doesn't stop. It is very, very quiet, very, very slow. It's not going to do any good at that speed in your case. It's just going to, not good. So let's get it back up to speed. Well, that's interesting. Now let's try the M plus M minus. This is for modes of the fan lights. Kind of cool, right? Lots of modes. All right, and finally we've got these that looks like the sun on them. So let's find out what that means. So I guess that is supposed to affect the coloring on the mode. Yeah. Anyways, and there's also auto at the top. So this is a very nice hub. Does a great job. And yeah. Hold on. Now, this one is really, I'm going to be honest with you. This one is kind of bending the boundaries between the hub and the last one on my list, which is the controller. So a controller, and I've got two controllers I can show you. One with no case. This is a Copal fan controller that I got from EK Labs, I think, or no, EN Labs. And you can control up to 6 fans with these, and you plug them in over here. It's PWM control using SATA power connected to the power supply. You can also get a power adapter and plug it into the wall. The bad thing about it is it gives no indications of speed or temperature or anything. However, if you want to mount this inside, it's got double tape on it, so it's very convenient that way. So this would be more of, this is more like a controller, but it's, you know, it's like a hybrid between hubs and controllers. So what's the difference? So this is actually a controller. Why is this a controller? Well, number one, you can individually control every fan. Hubs, not necessarily. Number two, it's powered by the some other power than the headers. And number three, this one cannot be controlled by the BIOS or by software because, as you can see, there's no way to plug it into the motherboard. It would have to be plugged into just the power supply. So that's the difference with a controller. So this is a true controller, and I have another one that I can show you as well. That is, ow! Oh man, don't drop fans on your toes. They hurt. Wow, that stung. I should have kept my shoes on. Okay, so this is an Akasa FC Trio fan controller. It's not particularly good, but it's a great example. We have power going to the power supply using Molex, hooray, hooray. And then we have got 1, 2, and 3 fans that can be controlled for PWM. And we also have 3 thermocouples here. 1, 2, and the third one's dangling down there. Then that you can attach to whatever that fan is cooling to make sure the fan is doing a good job of cooling it. You can keep track because on here it will show both RPMs and temperature. Now, I don't recommend this particular unit because it is inaccurate. I've had times where it was saying it was revving really high when I just barely turned the speed on, and I've had other problems with it. You switch from one fan to the next visually here by using this button, and then you control the speed with these dials here, and you use that button. You can actually use that button for 2 purposes. One is to switch between Celsius and Fahrenheit. The other one is to turn off the display by depressing it long enough. And depressingly, yeah, the reason this is a controller and not a hub is, again, like the Copal fan, you have to connect it to the power supply, and there's no way to connect it to the motherboard. Ergo, unless you can devise some way to do it, you cannot have software or BIOS controlling either of these devices, which you may want that. Now this one and this one, obviously you can see another difference. This one comes with double tape, so you can mount it inside your case somewhere or on the back of your case where people aren't going to see it, but you can access it. This one has to sit in a drive bay, so that means you can't have a computer that has no bays. The bays have to be there, and they have to be, if there's like a cover over the bays and you open it up to mess with whatever's inside, there has to be enough space in front to make sure that you can access the the dials and see the digital display. That is why these are called controllers. But again, the Asia Horse is kind of a hybrid because you can connect it to the motherboard, and you've got power coming from the power supply, and you've got the remote. So, this is kind of a mixture. So if I have to choose, I'm going to call this a controller, but I would imagine that they might say this is a hub. My only gripe with this is that the fans that connect to this one are weak, and I cannot connect them to a non-proprietary hub. I don't even know if the wiring on these 6-pin ones is the same from one manufacturer to another, or if, like power supply units, they use non-standard wiring. They use their own organization of it. But theoretically, they should all be the same if it's a 6-pin or JST connector. But I just don't know. So it's irksome, and it kind of, for me, although I really like the controller, I don't like the fact that I'm kind of limited in what I can plug into. Well, not kind of. I am limited to what I can plug into here unless I want to remove plugs and add regular plugs, and then I can't use this anyways necessarily. It's freaking annoying. So I would rather not have something like this just because of that. Now, if you're looking at getting a controller, I can give you a little bit of advice on that. Number one, when you're looking at controllers, do you want it to be hidden and you just want to be able to control every fan separately without seeing any information, or not? So if you don't need to see any information about each fan, you just want to be able to set the fan to whatever you think it needs to be at, you'll want to get something like this. And there are lots of these out there, not just that brand. That actually is an old one. There are much newer ones out there. However, if you want more control, you want to see temperature and RPMs and whatnot, then get one of the ones that has the display. Now, it doesn't necessarily have to be the kind that fits into a bay, right? Because you can figure out a way to have the power supply cable sticking out so that you can have it sitting or attached nearby. And I used to have this mounted on the underside of a table, which kept it stable so it didn't fall because I didn't have anywhere to put it. You could actually build your own cover for this so that you could have everything where you needed it to be, but it wasn't exposed like this. Yeah, so think about that. Also think about, what kind of connectors do you need? Are you dealing with both DC and PWM fans? Do you need the cross compatibility, or do you just need one kind? Are they 2-pin, 3-pin, or 4-pin? And be careful, because not all PWM compatible devices are actually PWM compatible. You'll see some that claim to be PWM, but instead of having 4 pins like this one and that one, have only 3 pins. And that means it's not truly PWM, because they have omitted one of the pins, and that would be the signal pin. Therefore, you're not getting true PWM support. And that can make a difference, especially if you're interested in the reports of the that are going on from that fourth wire. You also want to look at what kind of power source do you want to have. Do you want it from a wall outlet? Do you want it USB? Do you want it to be Molex or SATA or something else? You're going to have to decide that. And I would also suggest that if it doesn't have a display, and I haven't seen one like this yet, but if you get one that just has like dials or what do you call those, sliders on them, make sure it has gradations so that you can see what percentage you're turning it to. Because like with this Copo fan, I have no idea. I mean, they start here and then they go all the way around to there. So, you know, if I can see it, I can use my eyes and say, well, there's a probability that if I put it, well, not a probability. If I put it here, obviously it's off. But at what point is it going to turn on? Because this is not a high quality controller. The capacitors and I think it's inductors that are here are lower quality ones. They do not provide the range that is necessary for full control. So at what point is this actually going to start allowing things to turn on? So try to go for a higher quality one. I wish I had a higher quality one but I'm not able to necessarily find one that has enough quality without costing like $200, which is just like, it doesn't cost that much to make it. I don't have the technological ability to do that, unfortunately. So that's the tips I can give you right now on choosing a controller. Again, if you want to be able to avoid using software, then you want to use a controller. If you want to have control via BIOS software remotes, then you need to look at the hubs, because they get power from the computer, the power supply unit, but they are connected to the motherboard. And again, that's a difference. That's why the Asia Horse is kind of a hybrid between hubs and controllers. So that's it. Thanks for watching, and I hope you have a great day. In conclusion, I'd just like to add that you need to pay attention to several factors when you're deciding if you need an adapter, a splitter, a hub, a node, a repeater, or controller, or whatever. So, you know, consider, do you need something powered by the power supply? Or do you want something that can be controlled by the motherboard BIOS and or software? How many amps do your fans draw? Do you have a lot of amps total? Do you have a lot of fans and not very many headers maybe? And all of these other things that I've been talking about in this video, you need to consider all of those things. A lot of people can get away with just using splitters or even just using the headers that they've got on their motherboard. But sometimes people will buy ARGB fans only to realize that their motherboard doesn't support ARGB, because not all fans do. It's pretty new technology. So yeah, you need to pay attention to that too. You may even have a really old motherboard that doesn't support RGB. So you have to also look at that. Do you want a remote control? Do you want to have to reach into your computer in order to change something? If not. So consider all these things. I would say that if money's an issue, go for the cheapest thing that you can afford as far as type. I'm not saying buy the cheapest brand or the cheapest model. No, because, you know, like with this thing, I wish I hadn't bought it, because I can't effectively do what I need to do for my testing because it's substandard, which explains why Mikasa doesn't sell it anymore. So yeah, if you can afford better and you want to future-proof, which some tech people don't understand, and that's on them, not on me,
If you want to future-proof your computer for things you might add on later on as far as fans are concerned, then get something that's more flexible. And just watch out for proprietary stuff, because every time you buy a proprietary item, and it's not the same as other items in your case, that means that you need another adapter or another hub or another controller or something, and that can be frustrating. It'll also take a lot of extra space. It'll need more wires. So, make sure you're staying within, and my recommendation is avoid anything that's got a proprietary connector. Just get stuff that has the industry standard connectors. And that way, the vast majority of products out there will be usable by you without cross-compatibility issues, without proprietary problems, and not getting locked into one company's technological ecosystem, so to speak. That's it. Please don't forget, like and subscribe and share my videos so that I can help more people. Thanks for watching, and I hope you have a great day.